My background, even though here in Hawaii, I have mostly been known to do a lot of modeling work. I did spend many years in the Amazon as a forest ecologist. But here in Hawaii, I have been doing a lot of work on trying to determine the ecological impacts of climate change to our native biota, primarily focusing on plants and on forest birds. So it's kind of challenging talking about climate change and its impacts on Hawaii, because it is, Hawaii is an extraordinary place for many different reasons. And one of them is the fact that if Hawaii only accounts for about 0.02% of the land area, of the global land area. But if you try to map out the areas across the world that have climate that's similar to Hawaii in both in range of temperature and precipitation, that maps out to roughly about 27% of the global land area. So Hawaii has a small land area, but it's huge in terms of climate. And consequently, because of that, there's, because of that wide climate range, there's huge biological and ecological diversity across the landscape. So in the past, I have been asked to talk a lot about kind of what's the future of climate change for Hawaii and what are the implications and so forth. And I have spent a lot of past presentations, similar presentations, where I go into all different types of emission scenario projections and uncertainties in global circulation models, so on and so forth. Actually today, I'm not gonna do any of that, because this is really, at the state of the science when I started doing this only about 10 years ago, we didn't have the scientific studies, the literature that have been developed over the last years to understand really how the climate has already changed, is changing, and what are the ecological impacts. So today, I really will focus mostly on actually what we know, what has already happened in terms of climate, what are the current trends, and what are the ecological implications of those trends, and what we can do about it. So, a second, there's something weird here going on. Okay. So starting out, based on some good work from our colleagues at UH Manoa, we know that the temperatures are already rising in Hawaii. We don't have to look into the future about that. And in fact, that global temperatures here in Hawaii have been rising faster than the global average since about 1985. What's also interesting to note is that temperatures have been rising, but specifically the fastest rise in temperature we have for the state is our minimum nightly temperatures, which may bear some specific relevance to some important biological processes. I asked the Pacific Drought Knowledge Exchange to generate some climate data specifically to Hakalau for me to put part of this presentation, and I'll share some of those graphs shared by them, produced by them. And both the Hakalau units fit the same pattern. If we look back in terms of temperature trend for the last 30 years or so, we see the same temperature rise that is observed for the rest of the state, a pretty constant and robust rise. And obviously, we all know, as we, all of us in this room care about forest birds, we understand the consequences that that has had on our forest birds. We did some modeling in the past that looked about the projections of the additional warming to forest birds, but now we have a growing body of literature that shows that a lot of the patterns we're seeing in terms of like our native birds on Kauai and possibly Maui and so forth are seeing some really large declines that seem to be really strongly linked to that past and ongoing warming trends. But yes, if we do project out those temperature increases out in the future, we show that with any additional warming, we can have a landscape for our native forest birds that is radically changed between now and into the future. And in terms of plants, the science is still building up slowly because, again, the birds are so clearly impacted by rising temperatures that that signal has been a lot stronger and easier to pick. But we have a growing body of literature that shows that warming also has a potential broad impacts to our native plants as well. So for instance, we have now some documented, some studies that document range contractions for native plants here on Big Island based on the past few decades of warming. We also have some studies that document how temperature is associated to a wide set of demographic rates for some of our native plants. And one of our most well-studied native plants in Hawaii, the Hakalau silver sword, several of its demography processes are related to increasing temperatures, specifically in the dry season. And also we have some studies that show that in general, phenology is impacted, of our native plants is impacted by increased warming as well. Yes, sure.
Are you guys able to normalize that for habitat loss due to the
Yes, I think, well, all of these, I didn't conduct these specific studies, but I think based on the time range of those studies, I think that's mostly, yeah, so for instance, the range change at a study done in Mauna Loa, I think it was a study done for the 40-year time analysis that was done until 2016. So I would think that it would not have caught the brunt of the impacts. Also, due to some great work done by other climatologists here in the state, we know that the climate rainfall has already been changing for the state, in some places actually quite radically. So this work from Abby Fraser and Tom Jimbaluka shows that the leeward side of the Big Island actually has had a consistent drying trend in terms of precipitation for the last 80 to 100 years. And as you can see from this map, that pattern, especially for the Big Island, has been really pronounced on the leeward side of the island. And consequently, when we look at patterns of precipitation change for both of the Hakalau units, while there is no clear long-term trend in precipitation for the Hakalau forest unit, there's actually a really robust declining trend in precipitation for the Hakalau's Kona unit in terms of overall precipitation. And since drought is primarily driven by rainfall, but also increasing temperatures, what we see from some recent work by our colleagues is that there's been an increase in the intensity and frequency of droughts across the state. And looking again specifically at Hakalau, we see kind of similar pattern to what I just showed in terms of precipitation, where in terms using the specific drought index, we see no clear pattern for the Hakalau forest unit, but we see a pretty clear pattern of increasing drought at the Kona unit over the last 100 years. And as you expect now, there's increasing evidence of how these climatic changes can have a pretty big impacts across the landscape. We now have at least 2 different studies that show, looking at remote sensing data, satellite data, and airborne data otherwise, that shows that the vegetation responding accordingly to those shifts in drought conditions across the state, and especially here on the Big Island. And obviously those impacts on vegetation can have cascading impacts to our ecological systems and species that rely on that. So for instance, there's a study that associates drought patterns on palila habitat on decreases in seed production of mamani, and consequently impacts on the demography of palila itself. Another clear impact of increasing drought in parts of the landscape, a Hawaiian landscape, obviously is increasing fire risk. And there's some work done by Clay Trowernick that shows that how these continued drying trends for part of the state can actually lead to a lot higher risk for fire across the landscape. And the other thing that the other trend that has been noted in the literature in research recently is also there's been a shift in trade wind inversion across the state. And what that means is trade wind inversion is essentially the climatic phenomenon that caps the cloud layer below a certain level, typically about 2,000 meters or so. And that's essentially what creates a potential tree line because of anything above that that elevation is generally too dry. And obviously it's a phenomenon that's really incredibly important for Hakalau, as that elevation is just above the refuge, the Hakalau forest unit. And we have already shown that in some recent work that this increasing frequency in trade wind inversion days on Maui is leading to a drying of those at that elevation and leading to some pretty clear demographic impact to the Haleakala silver sword. And that impact has been very pronounced in impacting dry season precipitation. And if depending on what's the trajectory of that dry season precipitation into the future, that can really have an impact on the stability of those lower elevation populations for the species. So with all of this that I just presented, what is clear is that the climate under which we are all born into is a climate that's all in our past. And there's really no future climate scenario or emission scenario that gets us to the climate into which we were born. And we just have to really think about what that means in terms of, not on our own individual lives, but what it means in terms of how we manage the landscape under this now shifting baseline. And so what I wanted to show here is what are some of the kind of research projects that me and other colleagues at Pearson elsewhere are now engaged to try to come up with some answers and some tools to help us navigate that changing landscape. And obviously, Pierce, my research center, has a strong focus on Hawaii forest birds. And we have several projects that try to come up with answers that help us better manage this ongoing crisis. And one of them is just trying to understand what's that actual risk of avian malaria for forest birds across the landscape, and how can we use that information to understand what's the future of these species and how can we better manage according to those anticipated changes. So one thing we are currently working on is, I think we have always commonly talk about a malaria line as something that's sometimes thought as something static or across time and so forth. And what we are now doing in this research is, let me see if I can play, is we are based on some great lab-based work that looks at the thermal tolerance of mosquitoes and the Plasmodium, the parasite itself, the avian malaria parasite itself across the landscape. We're able to identify the thermal requirements under which mosquitoes and the Plasmodium is able to develop in situ, and therefore, under those conditions, becoming a greater risk to our native Hawaii forest bird community. So now we're able to model that pattern, essentially that shifting malaria line across the landscape dynamically day to day. So we're partnering this type of models with day-to-day climate daily temperature data from UH Manoa that allows us to then create a tool that will help us understand which places are at risk of particular from a particular heat wave events and so forth, and which places may be more or less vulnerable to additional warming into the future. And so it creates a tool for managers to understand those risks across the landscape. The other thing we also were doing is that we have also, not only we have thought about that malaria line as something somewhat static over time, but we have almost always thought it as something very much dependent on temperature, almost like as a bathtub bottle. As temperature increases, you have just malaria moving up in elevation. And in collaboration with Abin Paxson, we're now looking at some analysis that try to understand, okay, what other factors can actually mitigate or exacerbate malaria prevalence across our native forest bird community. And it's really interesting because we show that there's some really strong consistent factors that seem to either exacerbate or ameliorate avian malaria across native forest birds. And one of them is rainfall, meaning that, and what we're finding, and this is still preliminary, is that areas that are exceedingly wet actually have less prevalence than should be expected. And Hakalau and the lower elevation of Hakalau are in that category, meaning that perhaps it's not just a simple future scenario of increasing temperatures, meaning exactly increasing incidence of avian malaria to our native birds, which is somewhat hopeful. We're also trying to understand a key critical question about mosquito movement across the landscape, where we're trying to understand what's the capacity of streams to function as corridors for mosquito movement into the refuge under increasing additional warming in the future, because that would entail some potential ways that we can manage that risk over time. And it's still something preliminary, but we're collecting the data in the field, and hopefully we're able to understand whether there's something to this, and if there's something that managers can do about reducing that risk. The other thing that we have been engaged in a lot of our past work is just trying to think beyond individual species and thinking about habitat shifts and how that may impact our species. And so, for instance, we have been doing some modeling work that tries to understand, okay, given climate shifts across the landscape, which places are most climate resilient in terms of our restoration efforts, in terms of our conservation efforts, and how do we adapt our restoration baselines to this shifting climate reality? Because if we know, for instance, some particular places across the landscape are expected to be perhaps a lot drier in the future, should we be shifting our restoration goals over time and so forth? And we have a lot of different projects that are trying to address that and to help managers identify what's the best, what should we be shooting for in terms of those conservation efforts. The last thing I wanted to mention in terms of like relevant studies that we've been dealing with, that we've been working on, is just a reminder that obviously climate change is just one of many different threats and challenges that conservation here in Hawaii has to deal with. And so what we're doing is essentially bringing that same philosophy of like, how can we provide real-time tools that reflect a changing reality to managers so they can better react to a changing landscape. And we did that essentially with rapid ohia death, where we're partnering with several people here on Big Island. We're able to come up with real-time estimates of risk of rapid ohia death across the landscape and put it into a web tool that managers can then identify based on the current state of detections across the landscape, which places seem to be at greater or lower risk of rapid ohia death infection across the landscape. So one thing I wanted to just finish up with in a more hopeful tone is just that as I was preparing this presentation, trying to think about the implication of all this research to Hakalau, was trying to understand myself. Since I've only been to Hakalau a few times, I want to see, okay, what has been the changing landscape around Hakalau over the past few decades. So I just did a very simple cursory remote sensing analysis just to look at how what shifts has Hakalau and its context landscape has experienced. And I'll show you kind of that change over time, starting from 1991, which the earliest we have images for, into early 2000s, 2006, and so on. Up to pretty much the present. And I'll go back and forth again a few times, and we can see just a radical change across the landscape. And I thought that looking at this was informative, but also hopeful in a way that it shows, how, some people here actually in this room were planting trees over 30 years ago, and how that has the power of really reshaping the landscape over time. And you see really this massive reforestation within the refuge. And I think that just shows how powerful it is for us to have the capacity to change our future based on our efforts and our passions. But at the same time, I thought it was also somewhat symbolic of how conservation in Hawaii happens, in the sense that, you know, there are all these changes that we can do positively across the landscape, but there's also looming threats, as you can see with the gorse expanding, you know, looming in the background above Hakalau, and how that's been expanding over time. So I just wanted to finish up by saying that I hope that these different studies that I showed and this different science that I presented today just shows that we have an increasing number of tools that can be used for us to understand past, ongoing, and future change, and that hopefully that can help us better direct our efforts over time, and, you know, make some of the successes we have seen in Hakalau even greater in the future. So I'd like to just thank folks from the Pacific Drought Knowledge Exchange for providing some of the Hakalau specific data, for our podcast, for a bunch of the funding we got from some of these projects. And I guess if you have any questions, I hope I have time to answer.